Okay, welcome back. This is going to be a little different. As you can see, I changed my backdrop. Uh, so far, I don't hear the echo, tingy sound, so it's certainly colorful. And I think my audio quality should be fairly decent. Could always be better. I'll work on that. All right, so continuing on, communication and navigation. Um, Another pseudo navigation item is the ELT. Go ahead and get it queued up. Okay, how's that look? Decent. All right. Um, ELT, Emergency Locator Transmitter. Sometimes people refer to them as the black box, but uh, for the smaller aircraft, a black box is actually more of a flight data recorder or a cockpit voice recorder, as opposed to this transmitter, which is its main purpose is to send out a signal, usually upon impact, uh, a locating type signal, so that we can find the aircraft. It's independent from the aircraft's power system. It's got a battery, and there's a switch that automatically activates it, so no one has to actually press a button. It's activated by excessive G forces, and once activated, it does send a signal every 50 seconds on a frequency of 406.025, and some of the older frequencies also. And it will continue to send that signal for 48 hours or 2 days at a fairly high wattage. Typical setup is the transmitter, and it's got a removable battery, usually in the same case. So there's a cable, coax cable, that connects it to the transmitter antenna. I'm sorry, the transponders and transmitters antenna, the ELT. I'm getting my systems mixed up. Transponders for ATC. We talked about that last. All right, so where do you mount the antenna? Generally is far aft in a fixed wing aircraft fuselage in line with the longitudinal axis, so the center line of the aircraft. Helicopter mounting locations vary. Another antenna, other than what we've already seen, is the whip type. It's common, a thin metal rod that is connected pretty close to where the emergency transmitter is located in the aircraft. It's a good illustration of where they're usually located. As far aft as possible, and usually there's a access panel on the side of the aircraft, as opposed to access from inside the aircraft. Because of the low power output of the ELT transmitters, you don't want it to have to travel very far before it gets to the antenna. So the closer the better. A blade type of ELT antenna is used for higher speed aircraft. And of course, there's a regulation in Part 91. And what does it say? You may not operate a U.S. registered civil airplane unless you have an ELT that is in operable condition. And let's see, part C, batteries must be replaced or recharged if necessary, if it's rechargeable. If the transmitter's been in use for more than 1 cumulative hour, or when 50% of the useful life of the batteries has expired, and the expiration date for replacing the battery shall be legibly marked on the outside of the transmitter, entered into the aircraft maintenance records. All right, here we're showing the battery a little clearer, and the acceleration switch also. You may need to test the ELT operation. I believe I probably got a whole slide or two on that. Sure do. This is usually how you test it. You use a handheld tuned to 121.5, and you basically turn it on briefly and to see whether or not you're getting the clear signal onto your handheld. If you're going to do that, let's only do it for the first 5 minutes of the hour and for only 3 sweeps maximum. Don't let it continue on. Just once you get the signal on the handheld, turn it off. And air traffic control and search and rescue will know that it's just a test if it's done in those first 5 minutes. Question. The ELT battery must be capable of furnishing power for signal transmission for at least, how long was that? 36 hours? That's what, a day and a half? B, 48 hours? Or C, 72 hours, which is 3 days. It's actually the 2 days. 5 watts for 48 hours. The preferred location of the ELT is where? A, where it's readily accessible to the pilot or a member of the flight crew while the aircraft is in flight. Actually, it's quite the reverse. If it is on the inside, it's going to be behind a panel in the back of the aircraft. It's not going to be readily accessible. As far aft as possible, that is true. Or C, as far aft as possible, but forward of the vertical fin. And that is almost exactly where you're going to find them. Because otherwise you're going to be in the tail cone, and technically you're not going to be able to get very close to your antenna. So put it in just forward of the vertical fin or the vertical stabilizer. C. The ELT is normally activated by an inertial switch or equivalent mechanism if subject to a force of a prescribed intensity and duration. It must be activated when the force is applied A, parallel to the longitudinal axis of the aircraft, or B, parallel to the vertical axis of the aircraft, or C, in any direction relative to the aircraft axis. And I know we didn't really cover that. It might have been in that regulation. I didn't go much deeper into it. So basically, if you know your axes, you can actually differentiate between A and B, or C seems to almost be a fair answer if you're thinking about it. But if you remember what that switch looked like, it's not really a ball where something in the middle can go in any of the directions. It was pretty much set up so that the internal mechanism has to be in one direction. And that would more than likely, well, it is the direction of flight, which is actually the okay, parallel to the longitudinal axis. Okay, so basically, what is the switch being? How is it being centered? Longitudinal axis. Think of that as the long line down the center of the aircraft from the nose to the tail. So you definitely want it to go in that direction because more than likely, if a plane is going to crash, that's what is going to activate the switch. So A. There's G-force requirements of a TSO. In case you're interested, it's 5 Gs. And plus or minus, plus 2, so 7 or nothing less than 5. So 5 to 7 is where they want. And greater for a time duration of 11 milliseconds or longer, and that's a plus. So it's either not less, but you can make it go longer by up to, let's say, 11 to 16 milliseconds. So thousandths of a second. How may battery replacement dates be verified for an emergency locator transmitter and the ELT? How can you tell what the battery replacement date is, or how do you verify it? Well, where would you find it, I think might be a better answer, a better way to phrase it, I presume. Because, well, let's see. A. By removing the batteries and testing them under a measured load to determine if 50% of the useful life remains. Is that how you would tell what the replacement date is? No, that might be a different test, but it doesn't tell you what the date is. B, by observing the battery replacement date marked on the outside of the transmitter. That is probably the closest to what they're asking for. Or C, by activating the transmitter and measuring the signal strength. That also doesn't tell you about the battery replacement date. It doesn't tell you the date. It might tell you the condition, but it doesn't tell you when you have to replace it, irregardless of condition. And I'm not familiar with the rechargeable battery type, so it certainly would make sense, but I don't know if that's common. How may the operation of an installed emergency locator transmitter, ELT, be verified? How can you verify that it's working? You test it. Okay, basically they're asking how do you verify its operation. A, by moving the deactivating switch from the disarm position to the arm position while monitoring the civil emergency frequency with the communication receiver at 5 minutes after the hour. That's not exactly right, but it might be better than the other two answers. Come back to it. B, by activating the 5G switch and turning the unit on at 5 minutes after the hour. Also not a terrible, I'm still looking for a better answer. By C, by tuning a communications receiver to the civil emergency frequency and activating the ELT momentarily within 5 minutes after the hour. Okay, now that's what I was looking for. I didn't like the exactly 5 minutes after the hour. That's not practical. But any time within the 5 minutes after the hour. And it hits the requirements of what you're actually doing. Which the other two kind of do too, but the time is just not exactly right. And you probably did notice the 121, didn't we say 406 earlier? 406 is a little newer, more digital. And actually, you double the 121.5, you come up with 243. That's actually the third emergency frequency. So 121.5, double it, and then take the 406 for the more modern equipment. Coordinating, basically, those are the set rules. So you do not have to make any special contact with the tower on the test. And I've been in the field where I've seen them do the tests inside the hangar. I prefer to wait for the right time. When must the ELT battery be replaced? Other than just by reading the replacement date. So what are the other reasons you'd have to replace the battery? A, when the transmitter has been in use for more than 1 cumulative hour. I think I did see that in the requirements. Or B, must be replaced annually, or if the 5G switch has been activated. I didn't see that. Or C, when the transmitter has been tested more than 10 times. I didn't see that either. So A is the only one I saw, so that's the only one I'm answering. And that's when we went over 91.207. Okay. And what's the power source for an ELT? It's an oral question. I kind of like this question. Well, is it the aircraft power source? Not necessarily, because if you're talking an accident, I wouldn't count on the aircraft power source to power it for 48 hours. You're going to have a battery, an internal battery, integral battery. As long as you get the word battery, you're going to be fine. Internal. Which you kind of got to know what an ELT's purpose is, so you don't have to go too deep with this. You can certainly, if you want to continue on into avionics, go into that in much more detail. Describe one method of monitoring the signal output during an ELT test. So, how do you monitor it? One method. Right offhand, I can only think of the one method, but I would use my handheld tuned to the civil frequency of 121.5 or 403. within the first 5 minutes of the hour, after the hour, and for no more than 3 consecutive sweeps. Oh, okay, too much detail. And that is some of the problem with the oral questions. You'll be ready to give a long explanation, but because you are being asked so many in a session, they really just make sure you're hitting on, you're even starting to show that you know the answer. How would you determine if the batteries in an ELT are due for recharge or replacement? Observe it on the battery compartment itself. That's usually marked, a magic marker. And or if under testing, you determine that it's already 50% below its useful life, or if it has been activated for more than an hour. Which I think that would have had to been by accident. I'm not even sure why they have that. All right, by looking for the expiration for the recharge or the replacement on the battery and or the aircraft maintenance records, yes. At what times is a test of the installed ELT permitted? So what time of day is it? From the first 5 minutes of every hour. And for no more than 3 sweeps. Okay. All right, I guess that concludes another one. Thanks for joining, and I'll see you on the next one.